All right, what we're going to be doing in lab is one of the parts of this concrete experiment is performing something called a slump test. Now, there is an ASTM standard C143 that covers the procedures and the interpretation of the data from this test. We have a cone that's going to have quick clamps that we're going to be able to clamp down to a plate, and we're going to be putting concrete in there, and we're going to be doing that as a fun part of our lab. Now, what does a slump test do for us? A slump test is going to let us understand the workability of concrete. What do we mean by workability? Well, down here on the bottom right, we have a concrete pump truck pumping concrete to a site, and we're going to need to make sure we have the fluidity, the workability of that material to pump and flow into the forms that they're making. Now that's probably going to be different than maybe this top left up here where we're doing a slab of concrete where we're just coming out. Now we show a pipe that is kind of flowing out here, but a lot of times we may dump that out with a wheelbarrow and then come in here and just rake it out and smooth it up. So this may have a different slump or workability result than this. And so we would also want to look at the fact of when we have forms with rebar here in the center picture, that we're going to have the concrete easily flow around and fill those forms up. So we're going to have different amounts of workability associated to the process and the final product we're making. So let's kind of follow some of the procedures per ASTM standard and what we're going to be doing in the lab here. You guys, when you have your cone, first of all, you're not going to have to put your feet on the cone because we've got the nice little quick clamps. And you're going to be given a rod of a certain diameter. So take note of the diameter of the rod and the length of the rod that you're going to be given. You might put that in your lab sheet. And when you fill the cone, you're going to break it up into thirds. So we're going to come in here and fill this up into thirds, and that's going to be a lift. And so we're going to fill that up. We're going to tamp that rod down, not hitting the bottom on the first lift here. And you're going to do it 25 times. Now, you may want to angle that rod to ensure that you're getting down here in this area instead of if you just came straight down, you're not tamping this area down. The other trick is in the standard, they want you to go in a pattern all the way around and make sure you get the whole surface area in those 25 tamps. So you figure out how to get that to happen in your lab in terms of depth and how the displacement of the 25 tamps that you're going to do. Once you do that, you're going to come in and fill the second lift, and then you're going to extend the tamping into the previous lift by about an inch. And you're going to repeat and do 25 tampings in a pattern, getting that concrete to settle down. I put a picture over here that shows what happens when you don't do a proper job of tamping. You're going to have voids. This is a cross section of two different beams, one that's got a nice good feel, and this one has got imperfections. That's going to impede the strength or the properties of that material. So looking back at step 3, you guys are going to come in here and fill that last lift up. Now again, be a little proud, put a little more concrete than just the height of the cone there and tamp it down, because we're going to do something called screeding then. We're going to take that rod, roll it, and screed off that concrete after our 25 tamps, extending 1 inch in to the previous lift. Here we are using that rod to screed the top. So screeding is removing the excess material off that concrete. So you're probably going to knock some of that concrete down onto the plate and everything down underneath. You need to remove that after you screed the concrete off. And then what you're going to do is lift straight up. So you're going to unclamp it and you're going to lift straight up. Don't twist it or anything. Within 5 seconds, you're going to lift that off of the concrete that you've put inside that cone. What's going to happen is you're going to have to come over here, flip the cone. Notice we have the cone upside down. You're going to put the tamping rod across here, and you're going to measure from the bottom of the rod to how much slump you have in terms of inches. Here we have a picture of that cone flipped upside down, and we're measuring from the bottom of the rod down to the top of the concrete. Now we can have different kinds of results in this procedure. We could have a true slump, which is what we're going to want. That's our general working workability of our concrete. And so we're going to be measuring that in so many inches here in terms of slump. We have a shear slump, and again, you're going to be able to go through here and read some of these. This is dealing with cohesion of the concrete. We have true collapse. That's just basically going to run out, guys. That's the concrete is indication it's way too wet. If it's too dry, it's going to be a zero slump, and that's not going to have any real workability for it. That also, the amount of moisture in the water we have in there can interfere or enhance the hydration process of the concrete cure. So we're going to measure in this lab our slump result for your concrete mix that you guys are going to do and put that into your lab sheet and work from there. Now, when we look at concrete workability by slump, I put this slide up here because it talks about the measuring of this slump from the tamping rod, and different values result into different workability. So if it doesn't change much, a very low slump, to it has a lot of slump going on, that defines our workability. And again, we talked about that in the previous slides. If we're using something where we're doing walls, slabs, things like that, the different workabilities that we're going to want. So you guys are probably going to want at least a 2 to 4 inch slump would be nice. Now, once you guys mix your concrete, you're probably going to be stuck with that slump result, but now you're going to be able to record what workability level you had. So one of the goals of this lab, go through the processes, the steps of testing and evaluation and learning about these tests and how they're performed, going through that process so you can relate to the workers and how that's going to happen. Now, if you were going to buy concrete on a job site, you could specify the slump test results that the concrete needs to have, and the concrete company can change the slump results by different additives and moisture levels added to that concrete to meet your specifications.